So this is 7b97z39. It's line 22, 7b97z39. DARPA Rubidium Bose Einstein atoms superconducting lattice signals formula 5G Wow Seti. Here's our alien radio signal. This is a formula of atoms plus glass plus lasers plus crystals for a UFO space communications and travel vehicle found in the WOW data line 22. August 21st, 2013 is when I was working on it, and today's September 15th. Previous video is line 22, 7b97z38, Rubidium atoms, Higgs electric field, proton orbits, node signals, core UFO formula, 5G Wow Seti. Subwavelength-diameter optical fiber plus atom trapping, and guiding the keyword is Rubidium atoms, which I got from a blog, www.mpq.mpg.de. The quotes and diagrams are from PDF file results found on a blog. UI group creates a disordered insulator in an optical lattice by Celia Elliott, July 28, 2010. The rubidium atoms isolated in an optical lattice. Courtesy of DeMarco. Researchers in DeMarco's group at the University of Illinois have discovered a disorder-induced superfluid to insulator phase transition in a rubidium Bose Einstein condensate trapped in an optical lattice. Their results, which are the first experimental confirmation of recent numerical simulations that predicted a superfluid Bose glass transition, were reported this week in Nature Physics. We use techniques from atomic physics and apply them to long-standing questions in condensed matter physics, said DeMarco. This approach, using one quantum system that we can control to elucidate another system that is beyond microscopic control, is called quantum simulation and goes back to an idea first proposed by Richard Feynman in 1962. The microscopic effects of lattice defects and long-range electronic interactions, for example, are not well controlled in strongly correlated materials, and sophisticated theoretical approaches have reached inconsistent conclusions, said DeMarco. Simulating the impact of these effects on strongly correlated materials above absolute zero temperature is beyond the capabilities of even today's supercomputers. The DeMarco's group quantum simulator is a gas of ultra-cold 87 Rb atoms crystallized into an artificial solid using 3 pairs of 8, 12 nm laser beams. In their experiment, the atoms play the role of the superconducting electron pairs in a solid, and the light and that of the underlying ionic crystal. The researchers apply an optical speckle field using a 532 nm laser to simulate the effects of disorder on the lattice. According to DeMarco, the system lets us manipulate the atoms and introduce disorder controllably, so we can explore the effects of disorder in the weakly interacting and strongly correlated limit. Besides DeMarco, graduate students Matthew Panzinski, David McKay, and Matthew White carried out the research. The work was supported by DARPA, the Sloan Foundation, and CERC, and the National Science Foundation. The conclusions are those of the authors and not necessarily of the funding agencies. Okay, so that's physics.illinois.edu is where I found it. So the formula from the data on August 31st. Rubidium atoms, optical fiber wires, superlattice, superfluid fermions, ceramics, insulators, fiber optic wires, phase transition, Rubidium Bose Einstein condensate trapped in optical lattice, results, simulations, superfluid Bose glass transition, obsidian glass, mirrors, beads, Nature Physics. Techniques, atomic physics, apply long-standing condensed dark matter particles physics. One quantum dot, system control, Euclidate, another particle system, anti-symmetric, beyond microscopic control, quantum simulations. Richard Feynman, 1962, microscopic effects, lattice defects, crystals, long-range RF frequencies, Higgs boson signals, electronic interactions not well controlled. Faster than the speed of light, CERN 2012 neutrinos traveling error readings, strongly correlated copper, nanowires, atoms, materials, superalloys. Sophisticated theoretical approaches reach inconsistent conclusions. Combine that data with the simulations, impact of these effects, strongly correlated materials, superalloy tests with neutrinos. Above absolute zero temperatures, cooled plasma plus liquid argon gas, plus beyond capability of today's supercomputers. DeMarco group, quantum simulator, gas, ultra-cold 87 Rb atoms, crystallized artificial solid using 3 pairs ions, 8, 12 nm laser beams. My thoughts: we can change the shapes of the crystals and crystallize them into solid mass with these 3 pair ions and 8, 12 nm laser beam technologies. Back to the formula. Atoms play roles superconducting electron pairs, electron holes in solid structure, beehive hexagonal shapes, light underlying ionic crystal. My thoughts. 2 layers of crystals the same way you do graphite films for your collisions of neutrinos. You have superconducting electron pairs in the solids with visible light laser beams diffracting in between each layer of crystals. Researchers apply optical speckle field Google. Using 5.3 nm lasers simulate the effects of disorder on a lattice. DeMarco systems manipulate atoms, introduce disorder, controllably explore effects of disorder in weakly interacting W bosons, Z bosons, neutrinos colliding, interacting strongly correlated supercopper alloy C mixtures, inline 22 wild data formulas plus the limit. DARPA plus NSERC plus physics. The keyword rubidium atoms will be in the next video. Thank you for watching.